Asalamaualaikum and greeting everyone. My name is Ahmad, Farhan, Haniff, and Hisham. My matric number is B011820001. So, supervisor for me is IR, Dr. MD Harun Nizam bin Talib. So the topic that I will present today is about fuzzy logic speed control for DC motor drive. So what is speed control for DC motor? Speed control were used to minimize the difference between actual and desired speed. Fuzzy logic controller is a method of reasoning that resembles human reasoning, and the DC motor drive is a type of amplifier of power modulator that integrate between the controller and a DC motor. Now, here is the problem statement that caused this research happen. There have been many controllers that have been invented, such as PI and PID controller. This controller cannot perform well in non-linearity system. High overshoot that cause delay time to achieve the steady state of speed. Now we move to the objective of this research. The first is to develop a 4-quadrant DC motor drive system using H-bridge converter. Second is to design fuzzy logic speed control for DC motor drive in 4-quadrant mode. And the third is to validate the speed control performance by comparing several controllers with fuzzy logic in simulation results. Now, the scope of the project. This experiment fully done by using MATLAB simulation software. The analysis is about the permanent magnet DC motor for 4-quadrant system. The analysis for this experiment focused on the speed performance of the DC motor by using different type of controller, which is PI controllers and fuzzy logic controller. The permanent magnet DC motor designed are limited to only can use torque value of 4.6 Newton meter. The maximum speed that can be used for this paper is only at 1517 RPM. The fuzzy logic controller will be compared with PI controller in terms of time settling and overshoot present. For the second chapter, we'll be focused about the literature review. Research on previous study that were based on the fuzzy logic and speed control for DC motor. The things that will be analyzed from this chapter is about the overview of the project, main system that used, the parameter for project, results, and discussion. These are the things that have been done based on the chapter 2, which is literature review. So we had a project overview, main system, parameter, result, and discussion. These analysis have been taken from various of article and journal. It helped for my research, which is about the fuzzy logic speed control. Now we move to the third chapter, which is about methodology. There are several methodology that explain in this section, which is the first, DC motor 4-quadrant design. The second is about PI controller implementation, and the third is about the fuzzy logic controller design. So the first is about the DC motor 4-quadrant system design. So here is the system overview from this project. The first block diagram is about the speed control. And then the output from the speed control will be the reference input for the torque control. And then the output from the torque control will be used by hysteresis to control the IGBT switching. And then the IGBT switching are connected to the permanent magnet DC motor to perform the 4-quadrant operation. So the speed control and torque control have two input. The first is the reference, and then the second is the actual, which is for the speed is actual speed, for the torque control is the actual torque value. So here is the permanent magnet DC motor parameter system. So as we can see from the table, the maximum value for the speed is only 1517 RPM, and it used 0.5 horsepower and 120 volt rating. The rated torque that can be applied for this system is 4.6 Newton meter. So based on the block diagram that have been mentioned before, so we have the DC motor 4-quadrant system full circuit that used in MATLAB design. So now we have the control system, and then after the control system for both operations, speed control and torque control, we have hysteresis band, and then we have the switching system, which is we use IGBT switching mode, and then from the switching system are connected together to the permanent magnet DC motor. And also we have an external load that used in this research. As mentioned before, we also designed the PI controller. This experiment designed the PI controller to control the speed and the current for the DC motor 4-quadrant system. The purpose of designing PI controller is used to be the comparison for fuzzy logic controller in terms of the speed performance. So here is the controller system design for PI controller, and also here we have the table parameter that use to calculate the gain for both PI controller. Now we move to the main part, which is the main controller in this research, which is the fuzzy logic controller design. There are two types of fuzzy logic controller, which is Mamdani and Sugeno. In this research, the Mamdani type of fuzzy logic controller was applied in the speed controller. In this section, we'll explain the fuzzy logic controller design, fuzzy rule base, and fuzzy membership function. Now we move to the fuzzy logic controller design. So, the fuzzy logic requires two different input, which is the error of speed and the change of speed. The gain of GE, which is the gain error, and GCE, the gain change error, was obtained based on the equation 9 and 10, as shown in the slide. However, the self-tuning value for the gain was also implemented to get a better performance for the speed control. So here is the fuzzy rule base. A table that's shown in the slide indicated the rule of fuzzy logic of the system. The N membership represent the negative, ZE represent the zero error, and P represent the positive. So the set of rules for the system is defined according to 9 rules, which is 3 times 3 membership function. In the table, E represented the speed error membership function, CE represented change of speed error membership function. So in this slide, we'll be discuss about the fuzzy logic membership function. We have 3 membership function used in this system. 2 of it is the input, which is the speed error E and change of speed error CE. The output from the fuzzy logic is the change of output CU. So the fuzzy membership function is used to transform the crisp input supplied to the fuzzy inference system to the fuzzy inference system format. So all the membership function and range for fuzzy logic system were implemented in symmetrical design. Now we move to the result and discussion. In this section, the graph from the MATLAB simulating output will be discussed. As mentioned in the scope of the project, the analysis will be focused on the performance of the speed permanent magnet DC motor with 2 different types of controller. The main observation for this section is the comparison between fuzzy logic controller with PI controller in terms of 4-quadrant operation. Time settling and overshoot value will help the research to prove that the fuzzy logic controller can give better speed performance than PI controller. The first result analysis that will be discussed is about the step input performance fuzzy between fuzzy and PI controller. So the first graph is about the PI controller and the second graph is about the fuzzy logic controller. So, as observed, both controller can achieve the desired speed. However, the PI controller has an overshoot value of 6.67%, while the fuzzy logic controller didn't obtain overshoot value, which is 0%. The time settling for PI controller is 0.23 seconds, while the fuzzy logic time settling is at 0.18 seconds. So now we move to the step input performance between fuzzy and PI controller when the external load is injected. So the value of torque 4.5 Newton meter will be applied in the system at 0.3 second until 0.4 second. The purpose of this experiment is to observe the behavior of the speed when the external load were injected. As observed from the PI controller and fuzzy logic controller graph, both controller performance have an speed error of negative 50 rpm at 0.3 second, and at 0.4 second they have a speed error of 50 rpm. So now we'll be discuss about the main topic, which is the 4-quadrant performance between fuzzy and PI controller. So there are four operation: forward motoring, forward braking, reverse motoring, and reverse braking. So from both graph that obtained, the both controller able to perform 4-quadrant operation. However, the PI controller has an overshoot value in forward motoring and reverse motoring, while the fuzzy logic achieved the desired speed without exceeding the reference speed. Now we will look at the performance of 4-quadrant between fuzzy and PI controller when the external load were injected. So the purpose of this experiment is to identify the speed performance of the 4-quadrant when the external load is injected. So the error of the speed occur at 0.3 second until 0.4 second. Then as observed, both controller are able to perform the 4-quadrant operation even the external load injected into the system. As a conclusion, fuzzy logic controller proved to give a better performance than the other controller in terms of speed. This experiment compared the fuzzy logic controller with PI controller by using time settling and overshoot percent analysis. Fuzzy logic controller also able to give a better performance in all 4-quadrant operation for DC motor. Thus, the objective for this research achieved successfully. Now here is the last part of this presentation, which is the recommendation. For further study regarding fuzzy logic system, the fuzzy logic controller should be used and tested with a bigger system for permanent magnet DC motor, such as 5 horsepower. And then the fuzzy logic controller system should be implemented in hardware experiment.